Chapter 8, Experimental Design. As a reminder, an experimental method is a method of determining a cause and effect relationship. There are a few key requirements for an experiment. First is manipulation. We are adding or removing something to see if that causes changes in a variable. The thing we are adding or removing is the independent variable. The proper definition is the variable being manipulated to evaluate its effect on the dependent variable. The dependent variable is the thing we think will be changed, the variable being measured in a study. We also need a level of control. There are so many other variables that could affect the relationship we're looking at. Experimental control is eliminating the influence of an extraneous variable on the outcome of an experiment by keeping the variable constant in the experimental and control groups. For example, I study food decision making, and I know that participants coming into the lab right after a big meal might make different decisions than if they were hungry. So I have both my experimental and control groups fast for 2 hours prior to participation. However, there are so many variables and we cannot control for everything. So random assignment is needed as well. Random assignment is using a random chance procedure to determine which condition an individual will participate in. I like to use random number generators, but you could flip a coin or use other means. And essentially, this means that one, I am not biasing the study by assigning participants myself. And two, if there are other variables that might affect the data, like gender or age, it will be consistent across groups and not driving the changes we see. However, we can't always assign people to conditions, right? If we want to study how a new medication works in people with different types of cancer, we can't assign people to have different types of cancer. Or if we want to study long-term outcomes of children living in single-parent versus two-parent homes, we can't assign children to having one or two parents. But we can use a quasi-experimental design, which is a type of design that approximates the control features of true experiments to infer that a given treatment did have its intended effect. So you can't assign people to have different illnesses, but you can make sure they all get the same dose of the medication at the same time in the same hospital setting. There is still some level of control. Confounding variables are variables not controlled for in a research investigation that potentially influence the results. So this is when we don't know if the change was caused by the independent variable or if there is something else causing this effect. Going back to the food decision-making example, how hungry participants are can be a confounding variable. Whether or not they have an eating disorder is a confounding variable. And these confounds affect our internal validity, which, as a reminder, is a certainty with which results of an experiment can be attributed to the manipulation of the independent variable. Is this measuring what we want it to measure? Looking at basic experiments, the simplest experiment is one that has one independent variable and two levels of a dependent variable, typically a control and experimental group. With this, you could have a post-test only design. Post-test only designs are a true experiment design in which the dependent variable, the post-test, is only measured once after manipulation of the independent variable. Say you're interested in whether a new math intervention increases math test scores in elementary school children. One group of children get the intervention and the other doesn't, and then you compare. But you are only measuring test scores after the intervention has happened. You don't have a pretest or baseline to compare to, just what happens at the end of the study. There are some rules to follow here. First, there should be two equivalent groups of participants. You wouldn't want 100 people in one group and 50 in another. We also want to avoid selection differences, which are differences in the type of participants who make up each group in an experimental design. You wouldn't want, say, only gifted children in the math intervention group and only general education children in the control group, or those who hate math in one group and those who like it in another. We can avoid this with a random assignment to condition. We manipulate the independent variable where one group gets the treatments and the other acts as a control. So we need to make sure that only the independent variable is changed. We want to make sure both groups are still attending school and have a normal school day outside of the intervention. After the intervention, we measure the dependent variable in both groups. And if the kids who had the math intervention score higher on the math test than the control group, we can assume it was likely due to the intervention. This is a visual of this process. You have the participants who are randomly assigned to either the experimental or control group as part of the independent variable, and then you measure the dependent variable. However, you might want to get a pretest as well. Maybe we want to know not only if the math intervention increases math test scores, but where the children were prior to the intervention. Maybe the intervention group scores higher than the control group, but where were they to begin with? For this, we would use a pretest post-test design, which is a true experimental design in which the dependent variable is measured both before and after manipulation of the independent variable. The picture on the screen is an example of this, where the participants are randomly assigned to groups, just like before, but before taking part in the intervention, they take that math test. They then go through the intervention or control condition, and after that, we test them again to compare the scores. These pretest post-test designs allow you to do a few things you couldn't otherwise do. First, you can measure whether groups were the same to start with. Did the intervention increase math scores? Or did they just already have higher math scores to begin with? You can measure changes from pretest to post-test. Did the intervention increase scores a lot or just a little? It can also help to explain some attrition. Attrition or mortality is the loss of subjects who decide to leave an experiment, and it is a threat to the internal validity of a study. Say the intervention is over the course of a full school year, and after some time, some kids didn't want to participate anymore. They stopped showing up if it was, say, an after-school intervention, and you lose that data. But say that the ones who left were the kids with the lowest math scores who would have benefited the most from that intervention. It might look like that intervention was not effective. Having the data on who dropped out and what their original scores were will help us to identify this. We can also minimize this issue by providing incentives and being aware of the effects on participants, such as measuring their interest or engagement. There are disadvantages as well. First, it can make the study more time-consuming. You have to plan for the additional time it will take to administer the pretest. The longer it takes, the more attrition you have, and the less attention you have from your participants. It can also be difficult to create an adequate pretest that is sufficiently equal to the post-test without having an effect on the post-test. For a math test, you wouldn't want to give the same problems both times because students will remember the problems and have practiced them before. In this case, you would have to make a whole other exam with different but equally challenging problems. Having a pretest might also give away details about the study or impact treatment effectiveness. If participants know what you are looking at specifically, they might behave differently. One way to combat this is with the Solomon 4 group design, which is an experimental design in which the experimental and control groups are studied with and without a pretest. Here is a visual of that Solomon 4 group design. You can see that half of the participants get the pretest before being assigned to the experimental or control group, while half do not. And you would then be able to measure whether having a pretest affects the dependent variable or not. We also have to decide how we want our participants divided by groups. Between subjects or independent group designs are a type of experiment in which different subjects are assigned to different groups. This is treatment versus control, group A versus group B. And we would use random assignment to reduce biases between groups. This is the design we've been talking about up until this point. Within subjects or repeated measures designs are different in that the same subjects are assigned to each group. To change up the example, maybe you're looking at a new anxiety medication. Instead of assigning half the people to a placebo sugar pill or the medication, all people get both. Maybe participants unknowingly start with the placebo for 1 month and then have their anxiety symptoms measured. And then the placebo is changed to the new medication after 1 month. This way, we're not measuring two different groups of people, but measuring people to their past selves, allowing us to control for individual differences. When choosing an independent or repeated design, there are some things to consider. First, with repeated designs, fewer participants are needed because each person is tested in all the conditions. This can make it less expensive for the researchers and easier to get the number of participants needed. It's also easier to find an effect because we are controlling for those individual differences. There are some disadvantages of repeated designs as well, the main one being order effects. This is the effect that the order of introducing treatment or tests has on the dependent variable. This can happen anytime we are testing someone multiple times, and there are different types of order effects. First, we have practice effects, which is improvement in participant performance with repeated testing. To control for practice effects, you would need a control group, a group that does not receive the variable of interest. The control group might still increase if they are being tested multiple times, but if the experimental group increases even more, we can say that there is an effect of the intervention. Next, we have fatigue effects, which is a deterioration in participant performance with repeated testing. If you test someone multiple times, they might get mentally or physically tired. We can reduce this by making the experiment as short, easy, and interesting as possible, and having breaks scheduled in if needed. And then we have carryover effects, which is when the effects of one treatment are still present when the next treatment is given. If you are testing whether mindfulness or talk therapy is better at reducing anxiety, and all participants have already been in a mindfulness training session, they might already have reduced anxiety going into the next treatment. This can be minimized with adding time between conditions. Maybe you have them do the next task an hour later or a day later. Or you can add in unrelated tasks. I've used easy math problems or crossword puzzles in the past, but I've also seen researchers have participants read magazines or do other activities. We can also minimize order effects through counterbalancing, which is a method of controlling for order effects by randomly determining the order for each test for each participant. So if we want to know if mindfulness or talk therapy is better for reducing anxiety using a within subjects design, maybe half the participants go to mindfulness training first before attending talk therapy, and the other half does the opposite, receiving talk therapy before mindfulness. But this can get complicated when there are many conditions. Say, in addition to mindfulness and therapy, you also want to look at massage and physical activity. That's 4 groups. There are 24 different orders in which someone can experience these interventions. And that is too many conditions to keep track of. Instead, we would use a Latin square, which is a technique to control for order effects without having all possible orders. You would make it so each condition appears in each ordinal position. You can see that participant 1 experiences condition A first, participant 2 experiences condition A third, participant 3 fourth, and participant 4 second. Condition A, B, C, and D each have a turn showing up as condition 1, 2, 3, and 4. In addition to counterbalancing, we can also have a time interval between conditions, essentially building in a rest period. Going through each of those conditions in a single day would be incredibly tiring. Instead, maybe you have participants attend a session once a week, getting a different treatment each time. However, the longer the study is, the more attrition you may have. Match pairs design is a method of assigning participants to groups in which pairs of participants are first matched on some characteristic, and then individually assigned randomly to groups. We can match people on income, age, personality, or other variables to minimize group differences. The benefit of doing this is that there is more power than in independent group designs, where there are even more variables that are not being controlled for. However, the process of matching participants can be difficult because you have to do more searching for just the right groups of people, which means it's also going to be more expensive and time-consuming. For the activity this week, you'll answer the following questions to the passage below. Professor Foley conducted a cola taste test. Each participant in the experiment first tasted 2 ounces of Coca-Cola, then 2 ounces of Pepsi, and finally 2 ounces of off-brand cola. A rating of the cola's flavor was made after each taste. 1. What type of design is this? 2. What are the potential problems with this experimental design and the procedure used? How might these influence the results? 3. How could you revise the design and procedure to address these problems while still using a repeated measures design? Explain why you chose the particular design that you did. And 4. How could you use an independent group's design to conduct the taste test? What would be the advantage of this design? And that's all I have for you. If you have any questions, please let me know.